What if Earth isn't our final home, but just the beginning of humanity's story? For centuries, we've looked at the night sky and wondered if somewhere, out there, another world like ours is waiting. Blue oceans, familiar clouds, a second cradle for life. But as our own planet changes before our eyes, that question becomes more than curiosity. It becomes survival. New discoveries from NASA and the James Webb Space Telescope now suggest that another Earth might already exist, orbiting a distant sun in the perfect Goldilocks Zone, where water flows and life could begin again. The only question left is, how close are we to finding it? Stay till the end. Because what we're about to uncover might redefine what home really means. And if you love exploring cosmic mysteries and the future of humanity among the stars, subscribe because this journey is just getting started. Where life can begin. Not too hot, not too cold. Just right. That's the essence of the Goldilocks Zone, the orbital distance from a star where a planet could sustain liquid water. It's the key ingredient for life as we know it, the foundation for every biological possibility. Earth sits perfectly in that golden balance around our sun. Too close, and oceans would have boiled away. Too far, and they'd have frozen into silence. It's an almost impossible coincidence, or a miracle, depending on how you see it. But now, we know Earth isn't unique. NASA's Kepler Space Telescope, launched in 2009, proved that the Milky Way is teeming with other worlds. Over 4,000 confirmed exoplanets, and likely billions more yet unseen. Among them are planets orbiting within their own Goldilocks zones, places where water might flow, where skies might shimmer, and where something could be breathing beneath alien clouds. Planets like Kepler 452b, orbiting a sun-like star just a little older than ours, an ancient cousin to Earth, and Kepler 186f, the first Earth-sized planet ever discovered in a habitable zone. Each new world challenges the belief that we are rare, and yet, the more we find, the more complicated the question becomes. Because habitability doesn't always mean livability, the false twins of Earth. For every planet that seems perfect, there's a twist. Many so-called Earth-like worlds orbit red dwarf stars, small, dim, and violently unstable. These stars erupt with solar flares that could fry atmospheres and sterilize entire planets. Kepler 438b was once called the most Earth-like planet ever found. Its temperature and size matched ours almost perfectly. But its sun, a turbulent red dwarf, spewed deadly radiation that likely stripped away its atmosphere long ago. Then there's Proxima Centauri b, the closest exoplanet to Earth, just 4 light-years away. It sits in the Goldilocks zone, but its surface is probably scorched by solar storms from its parent star. Each discovery reminds us, being Earth-sized isn't enough. You need stability, magnetism, and protection, all the unseen ingredients that make life possible. Still, even knowing this, astronomers refuse to stop searching. Because for every disappointment, there's another glimmer, another world whispering. Maybe this one. The machine that found new worlds. When Kepler launched, it changed everything. Before it, the only planets we truly knew were in our own solar system. After it, we realised planets are the rule, not the exception. Kepler's brilliance lay in its simplicity. It watched more than 150,000 stars at once, waiting for the faintest flicker, a star dimming as a planet passed in front of it. Each dip in brightness was a clue. Each shadow, a world. From those flickers came thousands of discoveries, revealing that the galaxy is bursting with planets of every size, every composition, every orbit imaginable. Kepler gave us a new truth. The night sky isn't empty, it's full. But every mission ends. By 2018, Kepler's fuel was gone and the telescope fell silent. Yet its legacy lives on in the data it left behind and the new telescopes it inspired. The All-Sky Hunter. Enter TESS, the Transiting Exoplanet Survey Satellite. Where Kepler focused on one patch of sky, TESS scans almost all of it. Since 2018, it's been watching nearby stars, searching for planets close enough for future human study. Already it's identified thousands of candidates. Planets like TOI 700d, roughly Earth-sized and sitting right where liquid water could exist. The difference is distance. These planets are near enough for Webb and next-generation telescopes to study in stunning detail. Kepler showed us what's possible. TESS is showing us what's reachable. And soon, one of these worlds may become the first real candidate for Earth 2.0. The James Webb revolution, peering into alien skies. If Kepler found the planets and TESS mapped them, James Webb Space Telescope, JWST, gave us something more. The ability to read their atmospheres. Launched in 2021, Webb is the most powerful telescope ever built. It doesn't just see planets, it analyzes their light, splitting it into colours to reveal what gases surround them. From this, scientists can tell if an exoplanet's air contains oxygen, methane, carbon dioxide, even water vapour. And that means one thing: we're not just finding planets, we're searching for life. Already Webb has stunned scientists with data from K2-18b, a possible ocean world with traces of carbon-based molecules. The next step is simple, but world-changing. Detect a biosignature chemical evidence of life. If Webb finds that, humanity's oldest question will finally have an answer. We won't just be the observers of the cosmos, we'll be part of it. Worlds between worlds. Not all habitable worlds will look like ours. Many planets out there are super-Earth's rocky worlds larger than Earth but smaller than Neptune. These planets, like Gliese 667, CC or LHS 1140b, could have stronger gravity, thicker atmospheres, and more stable climates perfect for life to evolve and flourish. Some may even be covered in endless global oceans, deep, ancient seas hiding unknown ecosystems beneath their waves. What's fascinating is how common these in-between planets are. The universe might favour super-Earths over Earth itself. And if that's true, maybe we are the anomaly, the fragile exception in a universe built for something stronger. But for now, all we can do is look, because even the nearest of these worlds is still impossibly far. Seeing them is the easy part. Reaching them, that's the real challenge. The dream of interstellar travel. To reach another home, we'll have to cross distances that defy imagination. Even at the speed of light, our nearest star is over 4 years away. At our current speeds, it's more like 70,000 years. Yet, humanity is already daring to dream. The Breakthrough Starshot initiative, backed by Stephen Hawking and Yuri Milner, plans to send tiny, laser-driven spacecraft to Alpha Centauri, our closest stellar neighbour. These probes, each no larger than a microchip, could reach 20% of light speed, arriving within just 20 years. They won't carry humans, but they'll carry our curiosity, our eyes, our questions. If they succeed, we might see images of alien suns and their orbiting worlds within our lifetimes. Because no matter how far, no matter how impossible it seems, the human spirit always finds a way to reach beyond the impossible. The edge of discovery. We've scanned the stars, we've mapped thousands of worlds, but we're still searching for the one that feels like home. Each discovery brings us closer, but also reminds us how vast the universe truly is. Maybe the next telescope will find it. Maybe the next century will. Or maybe it's already been found, waiting quietly in the data, hidden in a signal we've yet to decode. One thing's certain. The search isn't just about finding another Earth, it's about finding ourselves. The future beyond Earth. We've found the planets. We've learned their names, mapped their skies, and read their atmospheres. Now comes the question that burns brighter than any star. Can we live there? The dream of leaving Earth is as old as imagination itself. From ancient astronomers tracing constellations to modern scientists designing interstellar engines, one truth remains constant. Humans were never meant to stay still. We were born explorers, and now the universe calls again. But before we can move among the stars, we must learn to build a world from nothing. Terraforming 101, turning alien worlds into homes. Terraforming. It sounds like science fiction, but it's one of the most studied ideas in astrobiology. At its core, it means reshaping a planet's environment until it supports Earth-like life. Temperature, pressure, air composition, all rewritten by human technology. The first candidate is always Mars. Our red neighbour sits close enough to dream about, yet harsh enough to destroy the unprepared. Thin air, frozen soil, deadly radiation. But under its surface lies ice, the first promise of water. Scientists believe with enough heat, enough greenhouse gas, Mars could awaken from its cold slumber. Imagine black dust spread across polar caps to absorb sunlight, massive orbital mirrors redirecting warmth, a growing atmosphere trapping heat, turning frost into rivers. It could take centuries or maybe less if technology accelerates. But every theory begins the same way. If we can remake Mars, we can remake anything. Now extend that dream outward. Terraforming a super Earth, a stable, rocky planet orbiting another star might one day give humanity a second cradle. The methods are the same. Engineer the air, seed the clouds, and release Earth's life forms to rebuild the cycle. And somewhere far away, beneath another sun, a blue ocean could rise again. The builders of tomorrow. Every revolution begins with builders. From NASA's engineers to private pioneers like SpaceX, Blue Origin, and ESA's Aurora program, the groundwork for interplanetary survival is already being laid. Reusable rockets have slashed launch costs by nearly 90%. Robotic explorers are testing autonomy, navigation, and repair systems for worlds where humans can't yet walk. AI now guides mission planning, resource extraction, and even habitat design. Each breakthrough is a piece of the same puzzle: how to live off-world. The first cities won't rise on exoplanets. They'll rise on the Moon and Mars, stepping stones in a cosmic ladder. Domed colonies, underground bases, hydroponic farms growing food under synthetic light. And once we master that, the stars become reachable. The interstellar arc concept. If faster-than-light travel stays impossible, then humanity's next home will arrive by generation ship. Enormous vessels carrying entire societies through the void. Imagine a city the size of Manhattan, enclosed in titanium walls, drifting for centuries between stars. Children born in motion, growing old before reaching a destination they have never seen. It's not fantasy. Concepts like Project Daedalus, Icarus Interstellar, and NASA's 100-year Starship have studied how such arcs could work: fusion engines, cryogenic sleep, or self-sustaining biospheres, where life evolves while the ship sails on. Each design carries the same message: survival demands patience. To cross the galaxy, we might have to let go of the idea of one lifetime and think in centuries. Contact across light years. Even before we arrive, communication will be our lifeline. Signals travelling at light speed take years to reach us. So when the first colonists finally step onto another world, Earth will already be history to them. A message from home could take 10 years one way. By the time a reply comes back, the people who sent it may be gone. To bridge that distance, scientists are developing quantum entanglement communication, AI-driven autonomous networks, and even gravitational wave beacons, all designed to keep humanity connected no matter how far we go. Because the greatest fear isn't being alone, it's being forgotten. The ethical frontier. But as our reach extends, so must our conscience. Terraforming, colonization, and expansion raise hard questions. What if the planet we reshape already hosts primitive life? Do we have the right to change it? And if we don't, are we ready to wait until we find a world untouched by biology? NASA's Planetary Protection Policy exists for this reason: to prevent contamination of other ecosystems and preserve their natural evolution. But in practice, morality becomes complex when survival is at stake. Humanity may face a future where we must choose: save ourselves or protect what we find. The true Earth 2.0. Maybe the perfect planet doesn't exist yet. Maybe we'll have to build it, part technology, part biology, part faith. The search for Earth 2.0 isn't just about new land under a new sun. It's about evolution our own. Every discovery, every telescope, every spark of imagination is humanity rehearsing for immortality. We might not find a clone of Earth, but we might create something better, a world born from understanding, not coincidence. A planet shaped not by luck, but by choice. The final message. Home is a moving target. Look up tonight. Every star you see could be a sunrise on another world. Every shadow between them could hide oceans, continents, and skies yet to be named. The question isn't if we'll find another home, it's when. And when that day comes, when humanity plants its flag under another sun, we'll finally understand that home was never a place. It was a journey, one that began on a small blue planet and never truly ends. Outro: the call beyond the stars. If this journey moved you, if you believe the search for another home defines who we are, then don't let it end here. Subscribe. Stay curious. Because the next great discovery might appear in the next video, or in the night sky above you. The future of humanity is already written among the stars. All we have to do is look up.